Hey everybody, hopefully a quick little video with something that I had never seen on YouTube before. I was kind of interested in seeing it. So basically we're gonna look at some first and second order circuits today, some RC, well an RC and an RLC circuit. And I got the first one set up here, as you can see, is just probing across the capacitor there. Here is what the circuit looks like drawn out, and here's a quick solution for the differential equation. This is the first order differential equation for it is first order circuit, so first order differential equation. Just using initial condition of 0, where initially I'm going to be switching the circuit on rather than turning it off per se. And here is our solution to that equation, and now we can see if we can get the math to match our measured values here, or vice versa, I should say. Alrighty, so I'm probed, and basically I'm going to be switching it on right here, and let's see what we get. Alrighty, so there's a nice waveform for us. So I'm just going to turn on the marker, and let's just see where we're at. So we're at 300 milliseconds. That's fine and easy. I got a little Desmos page pulled up for us. So we're gonna go ahead and put We're gonna go ahead and put 300 milliseconds in there, and it looks like we should be getting a value. And then there's our, our solution to that equation, where I'm just plugging in the time value, and we should be about at 3.72 volts and 3.7548. I'm gonna call that pretty darn good. We should figure out the percent error there, but I think it's close enough for a YouTube video, for me at least. Alrighty, let's get the second order equation set up, and we'll look at that as well. Alright, so we got the second order circuit set up now. As you can see, got a capacitor and an inductor in there, probing across the capacitor. So here's the circuit drawn out. I'll go through this one a little bit slower, but it's again, I don't know if I've said this yet, but if you're looking for information on differential equations, I'm probably not the best resource. There's plenty of good resources on YouTube, like 3 Blue 1 Brown or any other well-known math YouTube pages. But basically, just getting it to a point where I can solve, with a characteristic equation, finding my zeros, and then I get my constants. This is the only thing I think that was a little bit different is, when you get to your second, starting with your first derivative, you want to solve in this way if you get to a point with current, so that you can find your coefficients there. Yeah, and then I basically took this out because, it goes to 0 almost instantly. And then here's the equation for capacitor voltage, and just integrated this part of the equation right here, get to finding our actual equation we want after doing a little bit of work there. And that's basically where we are. So that's our equation. So let's go ahead and see what waveform we get here. So I'm gonna set this up to run real quick, and let me go ahead and switch it. We're getting at 5 volts here. Alrighty, let's see. Okay, so we're at 280 milliseconds. And I think I actually kind of already did all this, but yeah, so we're at 2.8. So 3 point, and this is just me plugging in my time there, and it says about 3.59 volts there across the capacitor. We're sitting at 3.6872 measured, and I'm averaging as well, so there could be some points that are messing this up, especially with such a quick time constant for this somewhat older scope, but it's probably doing just fine with this. But yeah, we're off by what is that, like about 60, 70 millivolts. So really not bad at all, at least for, you know, something with my little rinky-dink setup here. So it could be a lot of factors pulling that either way. So I'm pretty happy with that value. Again, the whole point of today, I hadn't seen really any videos showing this being done. Just kind of looking at the transients on a scope and comparing them to calculated values. I'm sure it's something done in school from time to time and whatnot, but I never did it, or haven't done it, I should say, and this is me doing it, and hopefully somebody found it interesting. So thanks for watching.